Good afternoon. Thank you for joining us on our call today. My name is Katerina Ost from Transcat, and I'll be your moderator this afternoon. Our webinar topic is NFPA 70B and 70E changes and additions. This topic is being presented by Curt Geeting from Fluke. Curt has worked for Fluke for over 24 years. He currently is the Sales Application Manager. In total, Curt has worked 40 years in the industry, consisting of 14 years in test equipment distribution, 4+ years in manufacturing representation, NAED accreditation, Level 1 thermographer, Level 1 vibration specialist, and power quality SME. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Curt.
Well, good afternoon, everybody. Thanks for your time and attendance here today. Again, my name's Curt Geeting with Fluke Corporation. I'm in the industrial group. We have multiple divisions at Fluke. I'm out of the Philadelphia area. I cover Maine and North Carolina is my running around area and what's called a sales application manager. So what we're going to talk about today is NFPA 70B and NFPA 70E. So a lot of you might be familiar with E, which came out, the original version is 1997. And that really got involved with the arc flash and electrical safety of the person that's working on a live electrical circuit. In terms of not only the ratings on the panels, but the appropriate PPE gear that they had to put on. But there's been some major changes happening the last couple of years, and we thought this is a worthwhile topic since many folks are trying to be in compliance with these and really understand what NFPA 70B is all about, which may be totally new to a number of you. So National Fire Protection Association, right, is an organization that develops these codes and standards. And as you can see on the list, there's quite a few folks who actually have used these as references and standards, and one of those happens to be OSHA and the EPA. So are these enforceable? Yes, they in fact are. And so obviously those companies like yourselves who may be listening in here today, trying to figure out how do we stay in compliance with these things so that A, we operate safely, but also we don't run into a situation for being out of compliance, in which case there could be some repercussions of that. So E, again, is primarily just really around the electrical safe workplace application. And it was updated in 2024. So what we're going to touch on today are what those updates are, and then introduce for those who don't know what NFPA 70B is all about, which really gets into the standard for the electrical equipment and the maintenance. And that includes not only the equipment, but the electrical circuits that they're connected to. And this was updated in 2023 with some major changes. So the organization, if you can see in the bottom right corner, is nfpa.org/en for English, if you're looking to find out more information. So what's new? So NFPA 70E adds new articles or renditions, and they call them, in this case, Article 100 definition. And we get into general safety, batteries, battery systems, and capacitance. And then they have new references for safety and maintenance. So obviously, in the world of testing, which we are involved with, obviously, if I can test a device, I can determine not only its operation, but is it safe? So there's a lot of clarification in this one around the electric shock batteries and also thermography, or thermal images, many people call it. NFPA 70B went from a recommended standard to a standard. So a recommended practice is one that doesn't necessarily say you have to do it, but when it becomes a standard, it kind of enforces you to comply with this. So really, this starts to get into a whole nother category of maintenance intervals, environmental condition of the maintenance, and the equipment itself from a standpoint of being safe. So properly maintained equipment is, generally speaking, safe equipment as well. Some of this may look familiar. And for those who might be in like an EHS type program, environmental health and safety, or a safety officer within your company. A lot of what we're showing you probably is not new. So obviously, numerous types of the devices are used to protect the individual, but then we put boundaries, obviously boundary being a distance from the area, to help alleviate the possibility of there became a problem. Arc blast, again, is literally an explosion of electrical panel or device, and can produce a lot of very damaging things coming at you, including, high velocity shrapnel and acoustic shock wave and a lot of things. Let's just put it this way: you don't want to be in front of one of these. So we in this industry have actually done great lengths of putting a whole lot of protection into the equipment and the meters that we manufacture, but also instruction around electrical safety as a concept. But what really started to change now is to get into batteries and battery systems. So I'm sure every time you get on a plane, every time you ship something, somebody asks you, is there a lithium-ion battery or a battery system in this package or on your person when you're getting on a plane? And there's a reason for that. Batteries do have the ability over time to heat up, to catch on fire, and can explode as well. And so what we're starting to see is this proliferation of all these batteries, particularly in the industrial worlds, and certainly renewable energy, but safe storage. So UPSs, things like that for use for backup energy or power in your plant or your facility, now are all ones that have to be measured and tested on a regular basis to determine, do we have problems? So to back up a step, again, 70E, the Annex S, really gets into the condition of maintenance. Now again, that's an electrical safety standard, but is the equipment well maintained or poorly maintained? And obviously the object of all this is properly maintained equipment will be safer or should be safer. And that's the idea. If we talk about it from standpoint of B, this is also giving the worker who's working on these types of pieces of equipment and circuits be able to assess the condition in terms of the maintenance or the electrical health of those electrical circuits. So that's kind of the definition. If you think about it, E is really the individual, and B really gets into the equipment and the circuits that an individual would be working on, if you want to put a kind of a dividing line between these two. So maintenance of equipment improves safety. Lack of maintenance or no maintenance leaves things a question, doesn't it? If you think about it. And I think that's in short where a lot of customers and people get in trouble, because they don't properly maintain the equipment, and then they end up with safety issues. So we're trying to eliminate that, right? So this is some of the ways that people will determine the condition of maintenance. So obviously, I'm walking around my plant, I'm looking at things. I see visual inspections. I want to make sure that everything is intact, that I've got lockout, tag out, that I've got everything properly labeled, that all equipment seems to be or appears to be in good working order. A couple ways we figure that out. Infrared energy or use of infrared imagers or thermography is one way. Generally speaking, when things get hot, they are typically in the course of dying. That's electrical equipment, that's mechanical equipment. So the phrase we use at Fluke, things get hot and they die. But before they die, other things can happen. And one of those could be an explosion, could be any number of things could happen. And if I happen to be an individual that's nearby, then that might be a tough situation. So we're going to take electrical measurements, voltage and current, which most folks know us for, obviously clamp meters and multimeters. Insulation resistance testing, as people call it, is looking at the electrical health of the insulation on a wire, on a motor, on a transformer. How much health do we have left? How much life do we have left in that piece of equipment? We can do that with what's called an insulation resistance tester, or we call it an IRT. And then battery impedance testing. So battery impedance testing really gets into testing on the live circuit or battery string, be able to test it. Now, keep in mind that a battery, if it's live, it's outputting DC voltage. I can't do an ohm measurement on that live, so I have to use what's called impedance measurement. So resistance is DC, impedance is AC testing, and the ability for us to be able to inject a signal in AC voltage through the terminals to look at the internal impedance or resistance of the battery cells and the floating voltage and even the temperature. So condition monitoring, you might have heard of. People are putting wireless vibration sensors and things of that nature on plant equipment to get a kind of an eyes and ears on it. And then other things that we're hearing in the marketplace and seeing are things like using ultrasound leak detection capabilities for doing things like partial discharge and corona. For those who don't know what that is, partial discharge is literally the breaking down of electrical insulation. Traditionally, it will be on a higher power circuit, but could be on high voltage circuits like in a switch substation or switchgear. And a corona is kind of this noise component of electrical arcing. It's almost a precursor of a future failure. So obviously, if two arcs join, as we know from Star Wars, bad things happen. So we can use this to determine that we have breakdown of this insulation and fix and repair this before we have an actual outage or electrical fault. But the big thing that's really being required here, the takeaway is maintenance history. Everything has to have a label on it. What we call asset tagging. And I've been doing this a long time. We see many plants that are up to this, and everything's tagged and they know where everything is and everything's labeled. So every physical asset has a physical location within the plant and what circuit it's on and how I'm maintaining that. And typically we call that CMMS software. So that's corporate maintenance management software. Might be folks like Maximo or SAP or those types of things. So you're going to have different companies out there that have these software packages that you can monitor. But the big thing is we've got to start keeping a history. If it wasn't written down or recorded, it didn't happen. And that's the way the inspection agencies and folks like OSHA are going to look at it. So obviously the maintenance of these records is key to know what's been maintained and what has not been maintained. So brief discussion in the beginning about thermography. I'm sure you're probably familiar with this. This is now required in the marketplace. It used to be a recommended practice, but it is now required. But obviously, if I'm opening up an electrical panel and I'm a thermographer or somebody taking a thermal image, there's this arc flash boundary outside of which you would not have to have PPE gear on, but inside of that or on the restricted area, you might have to have a full amount of arc flash clothing and insulated gloves and tools and all those types of things. But notice the specification here in the second paragraph. Only qualified thermographers can perform inspection within arc flash and limited approach boundaries. Now, what's a qualified thermographer? Somebody who's certified as a level 1 thermographer. So I'll bring this up for a reason. You might own a thermal imager, but not have gone through actually getting certified. We at Fluke have a relationship with a company that offers this capabilities, and the folks at Transcat can sell classes or seats of these classes to do these. Some of this can be done online, some of it can be done in person. Sometimes you can go to a local hotel where they're having these classes take place, and you can buy a seat at a class and get certified and tested and certified as a level 1 thermographer. Qualified electrician is the other, who has to be very much schooled in arc flash and limited boundary approaches in terms of the folks who are going to remove the cover. Now, there is a alternative to this. They're called infrared windows. It is something that we at Fluke do offer. What's a window? It's a arc flash or arc blast rated window. These are pure crystal that you can mount on a panel. And then I just flip down the cover outside, and I can do this without having to open up the door and have all the heavy PPE gear on. So they're all alternatives to not having to open that panel door. So previous years, recommended. Now, standard. What's the difference? This is now enforceable. So the verbiage has changed in B in 2023, not quite 2 years ago. Many people don't know this. This is the reason we thought this is a good idea to bring up as a topic, so that you are aware of the fact that this is now something that you do have to be in compliance with. It's not an option anymore. It's a standard. And so a lot of looks like inspectors, insurance companies, OSHA, again, EPA, are now enforcing this standard practice across the marketplace. So if we look at it from a standpoint of B, What exactly are we talking about here? So defines the fundamental testing methods of all the equipment. It shall be tested at intervals, depending on capacity. So that means basically you're required to go test things to determine, obviously it's electromechanical and safe health. And we use thermal imaging as a first pass. Again, things get hot before they die. So there's a lot here. I'm not going to read all the slides, and you folks will have access to all this. But basically, in a nutshell, you're going to have to follow standard procedures to do this. If you choose not to do it internally, then obviously you can hire a third-party thermographer to come on site and do this for you. And typically, this is done minimally as a once-a-year event. In some instances, it might be more than every 12 months or less than every 12 months, depending on the criticality of the equipment. So kind of a busy slide. Scope of work is on the left. I'm going to look at my electrical equipment. I'm going to figure out my scope of maintenance. What am I going to do? I'm going to figure out the condition of the maintenance of the equipment. I'm going to look at any environmental factors. So obviously, things that are very hot, things that have other components to it. They have dirt, they grease and grime. They have things that can actually start to degrade power conductors and insulation. You know, how is it being used outside the range it was designed for? I.e., am I running my motor hotter than it was actually designed for, which is going to be right on the nameplate? And what level of danger could be there if there was an absolute equipment failure happening here? So obviously, if you look at the three columns here, looking at the middle one for a moment, this is all what we call preventative maintenance. What do I mean by that? Typically, this is calendar based. On July 1st, I'm going to tighten, lubricate, and mechanically inspect all my motors, right? It's calendar based. It has nothing to do with the condition of the equipment. It has everything to do with the fact that it's July 1st, right? And so we're going to split it here. We're going to call that preventative. Predictive maintenance is on the right column. We're using electrical test equipment. We're doing corona or partial discharge with the ultrasonic leak detector, for example. We're going to do regular maintenance. We're going to be testing things on a regular basis. We're going to be servicing things. We're going to do special procedures or have contractors come in and perform additional tasks to maintain the equipment and or maintain its health. So you think about the scope of work, just looking at it from this standpoint, it's started to expand dramatically. If that hasn't happened yet in your mind, it will shortly. So two parts to this, if you think about it, right? Condition assessment. Well, what are we going to look at? The physical condition of it, the criticality. What are we talking about? Well, if it's a primary transformer feeding the power to the plant, if that goes down, what happens next? Well, the plant will come to a stop, won't it? So how critical is that? It's very critical, which means I might be looking at it more often. It might be the kind of thing that I'm going to look at every 6 months or maybe every 4 months with maybe something like a thermal imager. Or maybe I'm doing corona and partial discharge on that substation or that switchgear or that motor control center to determine we have electrical breakdown of the insulation, and it's starting to show up in the form of this electrical arcing event that is picked up as a high frequency event with something like an ultrasonic leak detector. So starting to get an idea where this is going. Now this is the real busy slide. I'm sure most of you, if you look at across these areas, are probably using a variety of these types of things. Are you running public pools, fountains, and similar installations? Probably not, right? Do I have photovoltaic cells or solar arrays sitting up on my roof, around my back? But if you think, these are pretty standard devices and systems we're talking about here. This is nothing fancy. This is pretty common in most either buildings and manufacturing facilities these days. So there's a lot there, right? Think about it. And again, keeping in mind, what are we supposed to be doing? We're supposed to be tagging all these as an asset. We're supposed to be putting these into a CMMS system to establish a history of maintenance and show actual evidence of the fact that I did do testing and I have maintained these things. So this is what they're talking about. So if you look at 70B, the scope of work that it now starts to entail is pretty wide. Now, can we do all this at once? No, you're not going to. What most folks do is they pick the most critical items first and kind of work down that list in terms of criticality. terms of what am I going to test and how often I'm going to test it, and kind of build a program as we go. And I've been doing this a long time. We have a lot of equipment that fits into all these categories. Doesn't necessarily people buy all this at once. They might start by program, let's say, doing thermal imaging first and get their feet underneath them with that, and then move on to the next topic as an idea. So, but worthwhile seeing. So this is kind of the scope of this. Now, these are the slides that you're going to go, wow, there's a whole lot here. Why am I putting these up here? Eaton Corporation, which we have a big partnership with and we use quite a bit as a reference, has established a lot of these things. And I pulled these right off the Eaton site. And I think it's worthwhile looking at this because this starts to get into more the nitty gritty of, it's not just visual, it's not just mechanical testing, it's electrical testing. Here's all the conditions again, condition 1, 2, or 3, 3 being the most critical, what am I going to go look at? And again, these are frontline devices. If you look at the right side of this page, we really get into the bigger stuff, don't we? Panel boards, switch boards, power cables, protective relay, substation, switch gear, UPSs, right? There's a lot there. Not trying to turn this into an eye chart. You're going to have access to all this, but I thought it was worth noting and putting this in there. So we're trying to give you some background information to work from. And yes, Eaton's a great customer, and once in a while they put a picture of one of our meters. In the bottom left corner, there's a Fluke 87-5, if you didn't notice what that might be. But again, it's more along the lines, what we want to do is, can we add some volume of information to you, as opposed to you having to go out and find all this stuff. So that's why we're doing this. We're trying to be helpful and give you background information that you can start to use today to figure out, where do we start? So, what are you trying to do? We're trying to maintain things safely, right? We're going to have to conduct inspections more often and maintenance and all the electrical equipment. That's going to be obvious. We're trying to maintain and improve the condition and the maintenance of the electrical equipment. So the philosophy at Fluke goes like this: you can't fix what you can't measure, right? I can't necessarily do all this with a multimeter or clamp on. You might be required to buy some higher level equipment to be able to do some of this if you're not hiring a contractor to do it for you. But you are going to have to conduct electrical thermography inspections on all equipment. That's a given now. So again, do you have the capabilities to do this in-house? Are we properly staffed for this? Are they educated? Do we even own a thermal imager? Right? All good questions, right? Ones you got to figure out. Does it make sense for us to do as an in-house function, or do we hire a third-party contractor to do it for me? That's a discussion you're going to have if you're not doing it today. So where we go with this at Fluke is we make a lot of tools. The whole line of Fluke is really written all around. If you think about it, what are we doing in our line? It's all written around predictive maintenance. And the idea that I could predict a future failure with Fluke test equipment. Everything dies, right? I think we all agree on that. The question becomes when. It's not if, it's when. So can I test and find future failures and pull to replace the equipment out before it breaks down, before we experience the downtime issue? Which, if we're not doing it today, at Fluke, we call this the cost of doing nothing. Now, that sounds kind of ambiguous statement as a cost of doing nothing. What's he talking about? Well, if you add it up every time something broke down, every time I lost an hour or more of production time, every time I had to air freight that motor or that transformer or that device in, every time I had to pay somebody overtime on the weekends, all this coming out of a maintenance budget, if you add collectively the cost of all those things over the course of your span, what kind of money are we talking about? I'm seeing in an average company, $100,000 a year is a low number, might be as much as $250,000 to $500,000 a year in lost revenue. That's the cost of doing nothing. What's the cost of doing something? Running a piece of equipment that allows me to see that future failure before it does. And so the idea here is real simple. You can't fix what you can't measure, but if I can measure it, I can determine its overall health and where is it in its lifespan. And now I can make qualified judgments to pull and replace before we hit breakdown. and take things down in an orderly fashion where I can actually plan for the outage and pull that motor or transformer at the appropriate time. So what we have here, and Katerina's, for those who send you this, I'm just going to mention this. If you click on any of these yellow links over here with the name of the Fluke product, that's going to take you to a link on their website, right to the Fluke product. So here's an example. This by no means is the complete lineup of what we offer, but there's quite a few things here. So it's a good start. So where we play in the marketplace and help people is we do electrical measurement safety classes. This is a free class. We can do this as a webinar, a seminar. We can come on site if you prefer. There's quite a few people across the US that are doing this, not just myself. We do offer level 1, level 2, and level 3. For an analogy here, if you're thinking about it, level 1 is your BA, your level 2 is your MBA, level 3 is your PhD. So, and we are aligned with a company called the Snell Group, which has the ability to deliver these classes. They're our international training partner in the world of thermography. We do motor drive troubleshooting classes and training. Why do we bring up motors? Well, motors are the heartbeat of any plant or any facility, right? Think about it. The motor stops, the fan stops, the conveyor line stops, the pump stops, right? Drives is variable frequency drives, just to put a fine tune on that. And we get involved with a lot of devices and instrumentation to be able to troubleshoot and get to what we call root cause. Why are things failing? And that's an important thing to think about. Can we determine that? Can we find that with you? Yes, we can, as a matter of fact. And we not only have the equipment, but we have the expertise to train you how to do it yourself. So none of this is rocket science, the way I look at it. This is all teachable and things that we can partner with and help you with through friends at Transcat. So I'm finishing a little on the early side. I think Katerina said 45 minutes. I might have talked a little fast there. Hopefully it wasn't too fast. What do you folks think? Is there thoughts, ideas, questions?
Yeah, so thanks, Curt, for that. That concludes our presentation portion of the webinar. We will now move into the question and answer like Curt was suggesting. Just as a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. So let's move on to the first question. Let me see here. Does installing an IR window void the UL listing on equipment rated less than 1000 V?
Less than 1000 volts.
Yep.
No. So we have quite a few ratings on our infrared windows, including all the way up to the nuclear power rating for used in a nuclear power plant, which they consider literally everything, including vibration and earthquakes and all sorts of things. So no, it does not. We have a UL letter that says that it does not derate the panel face, and actually the warranty of the window is the life of the gear itself. So there are what are known as arc flash ratings and arc blast ratings on IR windows. We can go as high as a 63 Ka arc blast, and we're rated up to 72,000 volts with it. So there is background information, and if Katerina, if this individual would like to talk more about this through you, we could arrange that and share all the data that we have in terms of the ratings and the application of the windows. Now, there is proper procedures, obviously, that has to be followed to install that window properly. That's number one. But we have that spelled out to great detail, and not very long at all. As a matter of fact, a number of our series windows can be installed by one person on one side of the panel in 5 minutes or less. But of course, we're not going to install a window with a live circuit sitting behind it, right? So we're gonna have to take that door off and mount it on there. But yeah, we have a lot around that, and I'd certainly like to share all that with the person that asked that question if we can connect with them through you and have a bigger conversation and share all that data with you. So we have all the things that qualifies us that no, we do not derate the panel based on everything we're showing. Now, you may have questions how it's being tested or rated. We have details on that as well, but we can share that with you if you like. And we are being installed actually in nuclear power plants, among other places.
Okay, we have a couple more questions here. So, what Fluke do you recommend for corona testing?
Well, we've had, so a little background. In April of 2019, we were first to launch into what we call sight sound technology. This is where we went from somebody who was wearing headphones had a ultrasonic leak detector in their hand and a wand to seeing it visually like we show on this screen right there. If you look to the left, that's a picture of an ultrasonic leak detector. The original offerings that we came out with in April 2019, the model II900 and II910 have recently gone end of life. The II910 was the model that we added in to the functionality and the firmware, the ability to do partial discharge in corona. The replacement for that now is a model called an II915, 915. And that replacement product hit the market in October of last year. So we now have three: the II915, the II905, which is just a regular leak detector, and then the II500, which is a low cost, just more like an air leak detector than anything else. Now, when I say leak detector, we're looking at compressed air leaks, hydrogen leaks, nitrogen leaks, argon, helium, just about any kind of gas, even a natural gas leak, believe it or not, we can capture on this. And the beauty of the technology is we're seeing the frequency of that leak coming through a small hole, and if it happens to be on a line that says natural gas, it's a natural gas leak. We don't have to calibrate it with natural gas or methane. There's no calibration really required on these at all. So the beauty of the technology is where we see the leak, and we can qualify that because when we see a leak, if we move and the leak moves, we know it's a reflection. But if we move and the leak stays put, it's a real leak, and we can document that. Partial discharge is something that will happen across multiple phases, traditionally in something like a substation on a high voltage insulator connector. And we will see that arcing effect, and we can see that several hundred feet away. Outside the fence, by the way, initially, you're going to want to get closer to identify where it's coming from, but we can quantify it as well. There's ways we can actually quantify the severity of that in the instrument. And again, this is a conversation we want to have with you directly so you understand how this works. Or come to a site visit and show you how it works in person, if you'd like.
Okay. How far down do these testing requirements go? Example, how low a voltage, how low a current? In the same vein, how small a facility?
Well, let's do this. What if we go back a couple slides? I'm going to just back up a few. Bear with me while I do this. I'm trying to give anybody a site problem here. Well, let's take a look. So low voltage ground fault protection systems. What's considered low voltage? Well, believe it or not, 1,000 volts or below is low voltage. I know you might think it's 480 is high voltage. It's not. Medium voltage is everything above that. Do you have lighting circuits? Are they 120 or 208? Yeah. So yes, that would be the case. Do we have battery systems? Those are what? 12 volt, 24, 48 volts? Yes. DC again. Fuses, GFCIs. Yeah, we could go pretty low with this, can't we? If you think about it. I'd say at least down to 120 volts AC, and then certainly all the way down to probably as low as 12 volts DC. If it's a fixed battery system, is all in the works here, frankly. Hopefully that answers your question and doesn't shock you too badly. We've got a lot of stuff going on here, right? Think about it. It's pretty wide range encompassing application if you think about it. It really is.
This isn't really a question, but this person said, very helpful information. When are y'all planning on the next webinar?
Oh,
No,
I pulled this one out because we saw all these updates and I was getting a lot of questions from customers. So I thought, well, there's probably a bigger audience for this, and that's why we contacted Transcat and said, hey, well, can we do this? What are you interested in? We cover a pretty broad range of topics. There's 13 different webinars and seminars we do, and just about anything you can think of. So grounding, insulation testing, power quality, oscilloscope training, process calibration, thermography, vibration analysis, ultrasonic leak detection, electrical safety, multimeter, clamp meter applications, HVAC troubleshooting. I mean, I could go on and on and on. There's lots of stuff that we get involved with. In the role that I'm in, what's called a SAM role, Sales Application Manager, there's 5 of us running around the country. Again, I'm doing Maine to North Carolina. So a lot of these can be done as webinar. We don't have to come on site unless you'd like to have us on site. So I guess, here's a question. If we put out a list with the folks from Transcat of the more popular ones, would everybody be interested in seeing what else we're offering? And let us know if maybe that's something we could do here with the folks from Transcat in the near future.
How often should your thermal imaging equipment be calibrated?
Oh, good question. So in the industry, generally speaking, if I'm just talking regular multimeter clamp-ons, regular test equipment, it's typically done on an annual basis. And there's the reason for that is everybody in the marketplace puts out an accuracy specification. What does that mean? It means I'm accurate for this limited span of time, and typically it's 1 year. If you're talking about a Fluke thermal imager, however, because of the fact we are a metrology company, I don't know if you folks all know this, but we make a lot of the voltage, current, resistance, temperature standards in the United States, all the way up to and including the National Institute of Standards and Technology. We are actually in that lab. We make some primary standards for the US government. So we're a metrology-based company who just happens to make test equipment. That's the way I state it. It's 2 years. It's a 2-year interval for a Fluke thermal imager. So the certification and calibration is good for the first 2 years. So I'll answer to you this way. If you bought one from us, you're good for the first 2 years. So in the 3rd year, at the end of the 3rd year, you would certify it and you'd be good for another 2 years. So in a 4-year span from year 1 to year 4, you would recertify it 1 time in the 3rd year. Okay, so we have high reliability, repeatability in the product. Why? Because we're a metrology company, and that's what we do. We make products that has a very repeatable performances, particularly when it comes to things like accuracy. So it's every 2 years with us.
How long do you have to get fully up to speed with testing and record keeping? I know that this just started, but are they giving you a grace period?
Yeah, that's a good one. I think, frankly, down in the bottom corner, https://www.nfpa.org/en for English. Would be a good place to go look that up. I can't tell you that, but being that they're the standards organization in this whole thing, they could probably give you a better idea what that looks like. Now, keeping in mind that NFPA 70B updates that we're talking about here hit in 2023, so this is not like it just happened. NFPA 70E, the updates, which include a lot of the battery stuff, again, happened last year. So I do believe there's some form of grace period, but I think like everything else in life, they're looking to say a good faith effort, right? Do you have the vehicles in place to do this? Are you accurate record keeping? Are you looking at probably your most critical assets first? So again, you're going to want to rank order. What are the most critical things in my plant that cannot go down, or major impacts are going to happen to us if we do? And that's probably the level of criticality you're going to start to build from. You're going to go from the top to the bottom. And so again, I think it's like everything else in life. You're going to take smaller bites of this and kind of work at it as time goes on. And yeah, you probably won't get it all done in a year, or maybe take a couple of years, but I think you want to ask these folks in terms of, to your point, how much grace period do I have?
What do you recommend for insulation testing?
Okay, so insulation testing as we know it, there's another name for it, but that's a brand name we're not allowed to say, so I'm not going to say it, is something that should be done on an annual basis. For most companies, things like motors seem to be the #1 thing I want to look at, and there's a reason. So let me give you a little point of reference, how this all fits together. On every device that requires to have insulation testing, you're going to have a nameplate sitting on it. And if you looked at a nameplate on a motor, what it's going to say is operating voltage, operating current, operating temperature. It'll be right on there. And typically for a motor or even a transformer, it'll be either 40 or 50 degrees Celsius. Typically everything's done in Celsius, not Fahrenheit. So if I use the example of a motor, I've been running it for a really long time and it's getting hot. The determining factor is for every 10 degrees C above nameplate, so let's say nameplate against 40 C, and now you're looking at with a thermal imager or maybe a non-contact thermometer, and I'm seeing 50 C, you've lost half the life of the insulation of the motor or the transformer or the cable. So all insulation fails as a function of temperature. When it gets hot enough, insulation will get brittle, it will crack, and it will fault. And if you think about on three-phase systems like a motor, there's actually 6 fault paths on that. Phase A to B, phase B to C, C to A to ground, B to ground, C to ground. It only takes one. If it gets to the point of fault, it's literally going to blow up. So I would be looking at the most critical ones if I were you. I don't know what business you're in, but if you have maintenance shutdowns, or we're walking around with a thermal imager and we see these overheated devices, you're going to want to shut it down as soon as you possibly can and test the insulation to see how much life or health we have left in that insulation. So rule of thumb, if you're doing insulation testing, so if we're testing, for example, a 480 volt motor, you would test it at twice the operating voltage. So that would be 1,000 volts DC. This is non-destructive. And what that does is it stresses it. So the analogy we use for insulation testing is if you've ever done your own plumbing, which I try not to because everything I do leaks. But how do I know I plumbed up something really good in my bathroom? Well, we're going to turn the water on full blast and we're going to look for leaks. We're going to increase the voltage and we're going to look for leakage current. So that current will actually start to travel across the outside conductor, and now that becomes a shock potential as well. So when my insulation breaks down, it means I'm getting end of life. And so an insulation tester is basically this. It's a go, no-go tester. Is there enough insulation life left in it to keep it running, or do we need to take it out of service right now? And so the combination of a thermal imager and an insulation tester are pretty powerful. If you think about it, we can see the health, see the overheating effect on that motor, that transformer, and know it's getting to the point where the insulation is being compromised based on the heat, and then test it with an insulation tester to do that. So if you're dealing with things that are low voltage, 1,000 volts or below, one of the more popular products we sell is called a 1587 FC. It's also a wireless device that will allow you to perform all the tests, but it also has a mobile app that we've been involved with for, oh gosh, almost 15 years now, called Fluke Connect. What Fluke Connect does is allows me to talk to this device and actually document the test, which is great for NFPA 70B because I've just documented the results of the test, and we can actually create an email out of this and store the data as an Excel, for example, so you can trend it over time. We do make higher voltages, so if you're above 1,000 volts, so we make a 5,000 volt version and a 10,000 volt version, and all those are also available as wireless tools as well. With what we call Fluke Connect, which is our wireless system that we started, it's 15 years ago now, I think. So take a look at that on the Transcat website. They've got lots of them in stock. I know they do.
Okay. You showed a slide that says only qualified thermographers can perform inspections. What is a qualified thermographer?
Okay, I figured we were going back to that one, right? I'll back up to that one again. So qualified thermographer is somebody who's certified as a level 1 thermographer. So level 1 thermography gets into the science of heat transfer. So for those who remember back in the high school days when you had the physics class and they were talking about conduction, convection, radiation, that's heat transfer. That's what we're looking at. Heat goes from hot to cold. So I can't see inside of electrical panel. I do have to open the door. When I do that, obviously now I'm in that restrict RF flash zone, right? But as a qualified thermographer, I need to understand that part. So that's what part of what they teach you, but they also teach you how to think thermally and understand what that image is telling me. So you get a certified and qualified eye. You understand what all the background concerns are, right? And why it is hot. And what is this telling me to interpret that, to know, do we have a specific problem? And where's the root cause? Why is it hot? And so that's why. So it's the idea that somebody has been qualified in the use of a thermal image and understands the application of it and also the interpretation of the image itself.
Okay. What does NFPA 70B really mean for my maintenance practices?
Well, to really document everything, it's if you haven't been writing anything down, it didn't happen. You're going to have to assign asset tags to things. Everything's going to have a label on it. You're going to have to create a history in probably some form of software. Again, CMMS type systems, corporate management maintenance systems, or software, I should say, is what we're talking about here. So again, Maximo, SAP, there's a variety of manufacturers of these out in the marketplace that have the ability to be able to trend all this data and create the proper documentation to prove to somebody the fact that we have been doing all these things. So I would say to you, identifying and tagging assets and using some form of software to trend all your maintenance procedures that you're doing on the equipment.
Does Fluke have a 2500 volt insulation tester?
By golly, we do. I forgot about that one. It's a, I have to check me on this one, Katerina. I'm not in the sales side anymore, so I have to remember. 1535 or 1537, I believe, are the two models. And they're both up to 2500 volt. Pretty sure those are the two models.
Okay. This is a comment, not really a question, but someone said, I use Fluke Connect all the time, and it's an amazing feature.
Ah, well, thank you for that. And you know, the other great thing about it, a lot of our tools, because of the fact they're wireless, so I use a wireless clamp meter, for example, like a 376 FC, which is Bluetooth, by the way, it's not Wi-Fi. I can put that inside the panel and I can talk to it through the panel door, which means this very picture here, that door's closed. And now I'm standing on the other side, the street closed, and I pull my mobile device out. So iPhone, iPad, Droid phone, tablet, it's all free. I can talk to it. And it is a data logger, it can record. I talk to a lot of customers who do a lot of testing and they stand in full arc flash clothing and they got the door swung open, their arms outstretched. Now let's see, I'm looking for that intermittent problem. There's a guy by the name of Murphy. I don't know if anybody's ever heard of him, Murphy's Law. And he says, that's never gonna happen while they're there. It's just not gonna happen. 5 hours later, all heck breaks loose. So what if we had this as a babysitting tool, a data logger, which it is, and it can data log changes on the circuit while you're off doing 20 other things unattended. And the battery life is the one variable. Please don't quote me on this. You'll have to look for it yourself, but somewhere in the range of 50 to 100 hours with the recording time, so several days worth of time. And then I can see those intermittent problems and I don't have to stand exposed in an arc flash suit and an arc flash clothing for long periods of time, which frankly, nobody wants to be in that anyway. So we get you out of the panel quicker and reduce your exposures to the arc flash situation or blast, and allow you to take that all that PP gear off and stand there with your mobile device and talk to it. And it's been a huge benefit for us to put out in the marketplace. And again, we're up to somewhere in the 70 to 80 meter range of meters that have this. Anything that says FC, as in Fluke Connect in the part number, is wireless and will work with the app.
What does a level, oh, no, we do have another question.
Yeah.
What does a level 2 or 3 thermographer get you beyond a level 1?
Okay. So what happens when you get a level 1 is you're expected to work X amount of hours in the marketplace as a thermographer to gain experience in the use of the product and the application of it. Level 2 really gets more in the higher level interpretation and the report writing piece around that. Because again, if you have somebody doing a thermography scan for you and all your electrical panels, the way they proved it out is they're going to produce a report, right? Which, by the way, a lot of insurance companies are going to ask you for. And they also probably will ask you whether or not the person who did it was a level 1 thermographer, and also show me the current certification and calibration on the thermal imager as well. So they'll be surprised if somebody asks you for all that stuff. They want to make sure, A, you know what you're doing, and B, is this a certified calibrated device, and you did all that with the capabilities, you know how to use this thing properly and interpret the data, and here's the report that came as the result of all that. So 3 is kind of a PhD level. That's kind of where you start to get into the, you're now the trainer kind of thing. I'm actually level 1. I'm going for level 2 end of September this year. Some point in my career, maybe I'll get to level 3. I'm not sure.
How would you get certified and what's the cost?
So here's where you're going to come in, Katerina. That person, why don't you send them a link to you showed me that you have on your website for our folks at Snell. And then there's different versions of the classes. Some can be in person, some can be instructor-led online, some can be self-paced online, some you can attend a class where they're having a class, and some hotel room in some major city in the United States, and basically buying a seat of the class. So there's different ways they deliver the content, and there's different prices as a result of that as well. So it's kind of tough for me to answer that question. I think it would be best if you talk with the folks from Transcat and they give you all the options and all the costs for all the different ways you could do this.
Yeah, if you type in Fluke applications training or just Fluke training on our website, it will bring you to them. We have a bunch, probably like 17 different options for online and in person.
Mm-hmm.
So.
It's great questions, by the way. Thank you. Appreciate the interest, attendance, time. Thank you for everybody who stuck around and got to listen to me or put up with me, one of the two. I'm not sure which. But we appreciate the time and the opportunity to be able to talk with you today. Anybody else?
Any other questions?
Right. My only question, I guess, for the folks who attended, we'd love to hear back from maybe response back to Transcat. Was this worth your time and attention today? Hopefully it was. We got some tidbits of information out of this that have educated a little bit further on these two topics. But if that's all, I'll say thank you for the time. Thank you, Katerina, for allowing us to address your customers here today. We appreciate that.
Of course. Someone did say this was a great presentation. Thank you. Thank you for attending.
Well, thank you.
All right, so that concludes our time for today. To find out more about Transcat's products and services, please contact us at 800-828-1470 or on the website at transcat.com. Thank you for joining us today. We hope you got something out of today's presentation and that you continue to join us for future Transcat EU webinars. Thank you.
Take care, everybody. Bye-bye.
Bye.